Hello, and welcome to today's episode of Rawkode Live. I am your host, Rawkode. Now, before we begin, I just want to take a moment to thank my employer, Equinix Metal. They provide the time for me to invest in producing this show and creating cloud-native content for us all to learn together. Today, we're going to be taking a look at Kubernetes and specifically autoscaling on Kubernetes. And to do that today, I am joined. Well, I messed that one up. I'm joined by my friend, Guy Templeton, an engineer for Skyscanner and the co-chair of SIG Autoscaling. Hey, Guy, how are you?
Hi, good, thanks. Yeah.
Yeah, I'm doing all right. I mean, until I removed myself from the stream instead of bringing you in, but that's the joy of live TV, I guess. So, do you want to give us a quick introduction about yourself, and then we'll talk about what we're going to cover today?
Yep. So as you already mentioned, I'm a software engineer at Skyscanner, and my focus there has generally been on sort of internal developer tooling, enabling Skyscanner's engineers to deploy workloads, build their code fast, etc. As part of that, for the last 2 years or so, I've been on the team that has been building out our Kubernetes infrastructure on top of AWS and migrating containerized workloads onto that. And that's involved, as part of that, I've sort of got more and more involved in the Kubernetes community over the time, with a particular focus on sort of cost saving and autoscaling, which has led to me becoming one of the co-chairs of SIG Autoscaling.
Okay, awesome. I mean, so let's start with the easiest question in the world. How about that? If I run my application on Kubernetes, does it just magically autoscale by default? I mean, that's a promise of Kubernetes,
right? Unfortunately not. Kubernetes is clever, but not quite clever enough to yet to figure out that it needs to scale things magically and how and what, where it should scale it, etc. So that, as with a lot of Kubernetes, there's currently a lot of dials there for people to figure out, like to choose the way their application scales. That can potentially be a bit overwhelming at the moment for users because there's so many dials for them to possibly change and figure out exactly how best to scale their workloads, how they expose the metrics they choose to scale their workloads, and make sure that Kubernetes understands those. And sort of that's what we'll try and cover today, scaling both in horizontal sense, and choosing your metrics, setting up those pipelines to get metrics available for scaling, as well as vertical pod auto-scaling. So the idea of adjusting the resources on single pods to meet their requirements.
Okay, so let's continue with a little bit of background, and then I'll get my screen shared, and we'll get hands-on with this stuff. Now, I guess the naive implementation and the people and organizations, teams that are adopting Kubernetes may do is just to, have loads of deployments of the applications and use the replicas field inside of their spec, set it to a big high number to keep their traffic satisfied. And that's not ideal, right? What you just said there was that, you're part of a cost saving initiative at Skyscanner to reduce costs. And that means scaling your application with the expected traffic levels at any given time. Would you say that using the replicas field on a deployment spec is almost an anti-pattern?
I would say if you're doing that manually yourself, yeah, that's probably an anti-pattern. I mean, a lot of these tools under the hood will effectively be manipulating those replica fields on a target, whether that's a deployment or similar. But yeah, I think if you're of the having to like go in at, say you've got predicted traffic spikes at 8 in the morning for some reason. If you're going in and like an engineer's going in at 7:50 every morning, going better scale up, edit, kubectl, edit, deploy. That's probably an anti-pattern, and there are ways that you can achieve that without having to have an engineer manually edit.
A cron job, right?
Yeah. I mean, you could do that. I'd still say it's not the ideal solution.
Yeah, I mean, obviously, I'm jesting, right? You know, we want this stuff to be slightly more sophisticated, which is where HPAs and VPAs come in. You know, we actually,
Yeah.
I've not looked at your example. I don't know what we're going to cover it. I'll speculate, but you know, we want to talk about using metrics from our applications to understand is the latency of the 95th percentile that we were responding to our customers with within our acceptable SLAs and scaling accordingly, right? I guess that
exactly.
All right. So all of the stuff we're going to cover today, you have published to GitHub, and it's public, right? So I can share this link.
Yeah. Yep.
Okay. So we're going to take a look at github.com/GJ Templeton/ well, I'm not going to read that out. It's there. So Kubernetes autoscaling by example. I haven't cloned it yet. As I like to do with this show is just discuss what I do up front, which is almost as little as possible. I don't think it makes a lot of sense for people to sit and watch me spin up a Kubernetes cluster. So we do have a Kubernetes cluster. This is good. There's always that fear, like I'm going to run get pods and it's going to say connection not found or something. But we do have a Kubernetes cluster. There's not a lot going on in this cluster. In fact, it's pretty much, well, there's a few things running on it, but that's not important. There's networking and there's some storage stuff, but no actual workloads yet. Right. Nice. So let's take a look at this repository. Let me try and zoom in on this a little bit so it's still readable. There is a dark mode now, isn't there?
Yes, there is under settings and
right.
It's pretty good.
It's right. I'll play with that later for next time. So this repository is consumable by anyone, right? Anyone can just come to this repository. It looks like you've documented it pretty well. And one of the things that you said when we were talking about preparation for this episode was that I could have just used a kind cluster.
Yeah.
I mean, I have access to bare metal. I decided we're not doing that. So and plus, sorry, Nico.
The kind cluster might stress your CPU and RAM a bit with all the workloads and scaling, but it just about worked on mine last night. So
yeah, no, I figured if I throw a bit more hardware at it, we could maybe have a bit more fun with the scaling rules and just see if we can push it through a little bit of a speed run maybe. So so feel free to check out this repository and follow along in your own time. Now, I'm going to assume, because I like to make loads of assumptions, is that we should start with the prerequisites.
I mean, it should explain to you what we expect to have.
All right, so kubectl, check. Working Kubernetes cluster, hopefully. Helm, yes, I'm positive I have Helm. Indeed. Okay.
Cool. Version 3. So awesome.
And we don't need to create a kind cluster. So prereqs checked off. Now you've broken this down into 4 specific sections. We've got resource metric scaling, custom metric scaling, external metric scaling, and then the VPA. Do you want to give us a little bit of flavor on 1, 2, and 3 there, why they're different and what they mean?
So Kubernetes, as with a lot of its functionality, sort of started from the basic autoscaling people were most familiar with. So that's like CPU or memory utilization. So allowing you to configure a target and say, I want this to I want to scale this and try and maintain like 70% CPU utilization. So some sort of sweet spot where you think you can scale up if more users start hitting your site, but also you can scale down and still keep a fairly good resource utilization so you're not burning money, as you mentioned at the start. That is a core API, and then over time, people obviously realize, well, I've got a lot of workloads that actually that's not the best metric. The CPU and memory are, either fairly constant or they're not coupled to the metrics that I care about, whether that's latency or if I know my workloads, my pods can serve a certain number of requests per second, and then that's the metric that I most care about. So over time, that effectively changes were made to the APIs to go through something called API aggregation. The idea being that the API server can then serve up can proxy a number of different APIs, and those API paths become metrics.case.io for resource metric scaling, so the original, custom.metrics.case.io for custom metrics, and we'll come back to sort of what the definition of custom metrics is, and external.metrics.case.io for external metrics, and we'll touch on that a bit as well. But those effectively should cover all use cases of a metric that you want to scale a workload on horizontally.
Sweet. Awesome. So let's start with the resource metric scaling. So first, make sure we can access the metrics API. I mean, can that fail?
By default, some setups of Kubernetes will come with nothing installed to serve the metrics API. So
yeah,
we can find out how your cluster is.
Yeah, metrics server is not available on my cluster, so this should fail. Oh,
yep.
Well, apparently that doesn't copy. So
okay, cool.
So that's these commands here, right?
Yep.
Okay, so I mean,
these commands. So the second command with the installation of the metric server, and I'm going to update this later, is you might not need all of those options. Those options are generally set up for a kind cluster. So you're using kubelet insecure and other bits to make it work with a kind cluster. That may not necessarily be required for all installations.
So this is a cluster API cluster, which is going to have a self-signed CA. So I believe we will still need the insecure.
Okay.
TLS.
Awesome.
And although I don't like the name insecure TLS, I think it's incorrect. I think it throws people a bit. I was going to say a really Scottish thing there. I think that's because I've got your accent in my ear, but ski with, like, you know, it's not insecure. We need to change our vocabulary there, I think. Okay, so preferred address, internal IP, insecure, we've covered. API service.create true. All right, I'm just going to go for it. What's the worst that can happen? So this deploys the metric server to our cluster, which starts collecting node-based metrics.
Yeah.
And that will now be available. That just might be the pod's not there yet. Is that right?
Yeah. It takes a bit of time for the pod to come up and basically register itself with the API server, saying I'm here and I'm serving this API.
I'm assuming that's going to deploy to the kube system namespace. No.
Maybe by default in that chart.
There we go. All right. I guess I should have maybe. Oh, if I was doing this in production, I would have tweaked that Helm command. So
yeah.
No metrics available yet. Now this, I'm going to make some more assumptions. Is that this is going to have some sort of Prometheus 10-second scrape interval thing? Is that maybe right?
Yes, it does.
Okay. So
I can't remember exactly what the default scrape duration is, but yeah, so as you said, basically the metric server is responsible for these days going out scraping the metrics endpoints of kubelets. That's why we had to pass in a kubelet insecure TLS flagging to get it working with self-signed certs, and that's then responsible for serving up those metrics through the API path of metrics.case.io. And as well as node metrics, it's also the one that's responsible for getting pod metrics through those same APIs.
Sweet. Well, we now have our top command working.
Awesome.
So we've got loads of cores, loads of memory. In fact, we're barely tickling this cluster.
Yes.
So we can have a bit of fun with this for sure. All right.
Very good.
And that takes a namespace flag. Let's just see what's going on. Why is copy paste weird? There we go. Okay.
Yeah. So as you can see, you can now correctly get through the API, like the CPU and memory usage of different pods.
All right. So, I mean, I don't mean to put you on the spot here and test your knowledge, but this metric server, I mean, this used to be built in. Was this previously the C advisor stuff that was deprecated, and metric servers are a replacement for that?
So the component that the metric server as a replacement for was something called Heapster. Yeah, that was built in and effectively had like pluggable backends. So you could, I think the default installation option was using InfluxDB as a backend. That had some slight problems and shortcomings with it in terms of certainly in Influx, we experienced a situation where we managed to fill the Influx backend because we'd scaled up our clusters without scaling up the Influx. It tried. And one of the problems it had was when you pushed data into, whenever you queried it, it first pushed data into the backend before querying it back. So it didn't hold a local state at all. So when you queried it, if it had dropped your data, it just went, I don't know, which wasn't the most fun. So yeah, metric server is effectively like built from the ground up for this very purpose.
Okay, cool. I've just realized this command will work because I haven't cloned your repository.
Oh, yeah.
Let's copy that, go back. It's running. Oh, I don't know why my... I mean...
I was expecting something to go wrong today, but it wasn't copy and paste.
It's always copy. I don't know what it is. I don't know how to Mac. Like I'm a Linux user. I'm trying to adapt. It's not going well ever. I don't understand why copy and pasting is so difficult. I'm sure it's trivial, and I'm pressing Control instead of Command or something. But it's perfect. All right. So we're going to deploy stress deploy. Now, before I apply it, I want to make sure you're not going to run a crypto miner on this. So. This is going to run program stress. So we're just going to be artificially hammering the CPU, I guess, a little bit.
Yep.
Memory stress as well. All right. I'll trust you. One. Stress deploy. I'm going to watch on that, so that's going to be pulling down the images, and it's just going to create some artificial loads. Let's see why we're doing this. What does it say? So you want me to run top pods? We should see them climbing, and then we're going. Oh, we're actually applying our first HPA as well. Shall we take a look at that? Oh,
yep. Ooh, there we go. Killed.
Was that supposed to happen?
No. And that may well be because the killer seems to be a lot kinder unkind than it is on actual clusters. So we can work around it for now by either we can raise the memory limit or we can remove the memory limit. I will leave it up to your discretion. Okay, so I guess I don't think on any of these episodes I've ever really spoken about these resource request limits. Yeah.
Why don't we collectively put our knowledge together and just talk about what this is? So the resource requesting limits is a way for us to tell, is it the kubelet that is responsible for the enforcement of this?
Yes, so the kubelet, I think is... I may be slightly off here. It's passing it down to the container runtime, which actually does some enforcement, but there's also component of like a bit of it that's left to the kubelet. So in terms of ranking the order in which to kill pods if resource contention actually happens.
Okay, so we're suggesting here by setting these resources, and we'll talk about requesting limits in a second, is that the kubelet may do something, but it also may just create the C groups with the CRI implementation. Okay, now, what is 50M in CPU? I've been asked this question before, and I've never had a good answer.
It is 50 millicores, which there is an internal piece called the CFS, or Completely Fair Scheduler. There is a long backstory to some previous issues with the kernel's maths and how it does it, but effectively what Kubernetes does is by default it has, I think it's 100 millisecond time slices, and these millicores are effectively translated into how much CPU time in a given bucket can a pod use of a CPU. So effectively, if I was giving it one full core, aka 1000 millicores, I would be saying it can use 100 milliseconds, the full 100 milliseconds of that bucket for a given CPU core. This is slightly complicated, obviously, given that in this case, we're definitely running on a big multi-core machine. So the CFS then comes in and basically does throttling, where if a container uses more CPU in a given slice than it should do, it will get throttled for the next few buckets of time to average out, so that a single container, given a resource, given a CPU request and limit can't basically use more CPU than it should be using.
Oh, sweet. That's a really good explanation. I think even I understood that, and I'm not the smartest, so cool. Now, this is an OM kill, so I'm going to assume that this has nothing to do with our CPU limits, and it's our memory limits.
Yep. We'll
bump that up. Now, do you want to... What's the difference between a limit and a request?
So in CPU terms, effectively you're saying for a CPU request, you're guaranteeing that on average this pod can use the equivalent of 50, in this case, 50 millicores. So 1/20th, is my maths right, of a CPU on average over time. In memory, you're in the limit, you're saying, however, if there's spare capacity in the CPU, you can use up to, in this case, the equivalent of 75 millicores of a CPU. So if there's contention, if the node is really highly utilized, so you've got a lot of CPU intensive workloads on, and all of them have far higher limits than their requests, they won't all be able to get up to their limits, but they'll still always get their requests. And it's the request that's used for scheduling the pods onto the node.
So this is still being killed.
The other alternative, because in the example HPA, we're only scaling on CPU, not memory. The other alternative you have is not giving it resource requests and limits. This is generally a bad idea, because it means that the scheduler doesn't really have much information about how much resource a given pod is likely to use, and that will result in can result in problems because you get contention.
Okay, well, they're happy now. Why is that not showing me the CPU memory one?
So it's the same thing we came to with the first call, in that it takes a while for it to first scrape the kubelet and discover those the metrics for those pods that have been newly created.
Okay, so we'll give that 30 seconds to catch up. What we'll do now is, firstly, because I forgot at the start, if anyone wants to try Equinix Metal, then you can use the code Rawkode-live at metal.equinix.com. $50 of credit is roughly around 100 hours of compute on a smaller instance, but using the smaller instance is not very much fun. So, spend it quicker and enjoy it. Now, we also have a comment. So Sampath has asked, does the memory, or can the memory go beyond the limit when we're running the stress command? And I think the answer is no. We just can't. When it hits the memory limit, the OM killer is just going to say, "Hey, you've had enough. You're barred," and kicks out, right?
Yes.
So yeah, you cannot go beyond the memory limit. And I think based on what Guy said a couple of minutes ago as well, is that you can go past the CPU limit, but you'll be throttled on subsequent requests to bring it back under the limit.
Yeah, and so this becomes a problem for really latency sensitive workloads, where if you're getting loads of requests fired in, respond really fast, hit your limit, like use up more than your limit within a time window, and then in the next few windows you're effectively throttled, that can cause your latency to spike because your workload's getting throttled, so it's not able to respond or do the CPU cycles it needs to respond. So you can you're able to like lower the window slice to try and combat that. You can remove throttling completely, like disable the CFS. Some users recommend that. Generally, it doesn't seem to be recommended for multi-tenant environments, so keep that in mind.
All right, sweet. So as we can see here, we actually needed just under 250 mega RAM for the CPU stress, and we needed almost a gig for the memory stress, but they both are happy now. So
it's stressing the resources as expected.
Yeah, I'm happy with that. Okay, so what we want to do now, okay, so yeah, we can see they're hitting the resource limits. Now we want to apply a horizontal pod autoscaler, or an HPA, to make that better. So
yep,
let's have a look. So this horizontal pod autoscaler, like we've got a version and a kind of metadata like we expect. Let's just kind of run through the spec side of this and try and understand what's going on. So yep. We'll come back to scale target ref. I'm assuming that's just like a label matcher on what. For example, I guess we're covering it now. So this is going to say, hey, what is it we're trying to scale? Is that right?
Yeah. So API version, so and kind, effectively we're saying it's a deployment in the apps v1 spec that we've got to scale. So there's a number of different resources within Kubernetes that all implement this behavior called scale, and that effectively is what this gets mapped to behind the scenes.
Sweet. We then set the minimum and maximum replicas that we want to accept for this, and then we define the metrics that we want to use as a benchmark for scaling. So if I can read this one correctly, then what we're saying is if the CPU of this pod is at 70% of its CPU limit, then it's going to add on more replicas.
Not quite. So there is an algorithm effectively that the HPA uses. So the HPA, unlike a number of the other things that SIG Autoscaling owns, that's actually contained within the core Kubernetes controller manager code base as a reconciliation loop, and that's got an algorithm in it, which effectively each time it's evaluating, you can configure that on the controller manager. It effectively does the maths of scraping the current metrics, or getting the metrics for the pods currently in the deployment, getting effectively what is their current utilization, in this case of the CPU resource, dividing that by the desired, so in this case 70, and then timesing it by the current replicas. So if we're using 100%, we divide that by 70, so we get 1 point something, that maths is off. Times that by current replicas, do a ceiling on it, and then set that as the new desired replicas.
All right. Okay, that makes sense. I like it. So we can just apply this to our cluster. And if we take a look at this, we can remove this replicas now, right?
Yes.
I gave a talk at GitHub Days about a month ago, where actually I was bold enough to say that setting replicas in either of these specs was an anti-pattern, and you should use HPAs in all scenarios, even for local dev. I'm not sure how well it went down, but I'm going to push it. So what this means is, because we have, in fact, it's already away, right? So
yep.
Because that CPU thing is always pushing against the limit, I guess that's what the stress thing is doing, is
yep.
that right away this is when, hey, you probably need more of these. And that's now starting to scale up. Okay.
So you can also see that one of the things you can do is the HPA is quite good at telling you why it's done a scaling action. So you can do kubectl describe HPA. Yeah.
Okay. Set the size of our replica set to 3 because the CPU resource utilization percentage of request went above a target.
Yeah.
Cool.
And you can see higher up, you've got the metric section as well with the current and the target.
Sweet. And then we delete. So that's it. That's
resource metric scaling. So you can also we set this up to scale on CPU. You can also do resource utilization scaling on memory as well.
Okay. And as a rule of thumb or a guide for anyone that wants to start using this, is this the first place you would start for workloads?
Yeah, I think it's unless you're coming into it with a real knowledge of like what the metric that's most important for you is. I think this is certainly the easiest to set up. Like the metric server is owned and supported by a core part of the Kubernetes community and SIG instrumentation, and it's well tested. So this setting up the metric server and setting up resource scaling is really easy, as you've seen. It's like in this case, one Helm chart to set up the metric server, and then a couple of bare YAML objects.
Okay, definitely. All right. Plus, they don't have to re-instrument their own application if they've not added Prometheus metrics or anything like that.
Yeah.
I'd say it's a good starting point too. All right, let's take a look at custom metric scaling.
Yeah.
What are custom metrics?
So, custom metrics are metrics which correspond to a Kubernetes object. So they're not just any arbitrary object, like whether external to the cluster, so something like a queue length potentially. They are either metrics that are exposed by each pod in a deployment, or potentially on other Kubernetes objects. So ingress objects are one example. So effectively, if you were deploying a service scaling behind an ingress object, you can make use of metrics produced by that ingress object, as well as a custom metric.
All right. So for this, then, we need to deploy Prometheus.
Yep.
Do I really need to port forward?
That is just to have a check if if you were unsure about whether it's set up correctly. But
okay, so Helm install. All right, let's see what we got here. Right, so we've got a node exporter, a kube state metrics, push gateway in the server, and alert manager. So the Prometheus server is obviously the database. We've got the alert manager for doing alerts. Why are those pending? Not like pending.
Yeah.
Oh, they request that. Yes.
There should be a way to disable that, surely.
So the problem is this cluster is not really configured for storage classes and PVCs. So let's fix that first. Let's go over here. Let's grab this Helm chart. I'm sure we can tell it to use a host path. In fact, I can edit it. Let's just do that. Edit, deploy, Prometheus server. Is it a stateful set or deploy?
You can disable the persistent volumes.
Ah, well, that's easier. Is that just a Helm flag I can drop in?
Yep. So if we go Helm upgrade,
What's the last values flag? Do you remember? Yeah, great.
No.
Reuse values. Okay, so Helm upgrade, reuse values, Prometheus set. What do you know the?
So there's where are we? It is. Come on, there's a lot of options in this chart.
Are you sure you don't want me just to edit the deployment?
Yeah, it might be easier to.
All right, let's see. So volume mount, okay, looks fine. Volume mounts, okay, we've got data here. Thing. Temp Prometheus.
That looks a bit better.
We don't really need alert manager, do we?
No, we don't in this case. So.
Oh, they're going to make me create that path first. Is that the problem? Oh, it was error, wasn't it? It wasn't.
Yeah.
See. Right, come on, you. Log -f copy. Oh, it was 9 anyway.
Oh, it's the other
one. Let's see, Prometheus server, and unable to create.
Open permissions to that. So I have found the command, the flag you want. It is server.
Use values Prometheus set server
dot persistent volume dot enabled equals false. Capital V.
Oh, great.
Yep.
Oh yeah, in the chart.
Oh yeah. The Prometheus community / Prometheus.
Should have used kind.
I'm taking notes for things that I need to fix for people not using kind to do it.
All right, container creating. So it's got no persistence, no PVC. Our crash loop backoff will disappear now that that's running. It's going to say terminating. It'll go away eventually. Right, we have what we need. That's important.
Yep.
Okay, so let's do the port forwards. Make sure we can browse to it. Make sure everything's happy. Post 1990. And we have a Prometheus. Now, because those node exporters are running, we should have, a whole bunch of status. So,
yep.
Disk, perfect. Go. All right. You happy with that then? So
yep.
Let's kill the port forward and go back to the tutorial. So now we're going to deploy our sample application. Let's take a look at our YAML. Sample deploy. So this is running some autoscale demo thing. Got Prometheus annotations, so it's going to be scraped by Prometheus. Yep. And more resource limits. Oh, and even a service now.
Yep.
Does it need to hard code the cluster IP?
No.
I don't even know if I don't think 10.
Yeah, that's
not even my service sider. So okay, so let's deploy. Yeah, let's deploy that. Okay, so we're going to apply Kubernetes scaling to sample deploy. We'll get the service. The IP, good. Yep, 172 is what I needed. We'll make sure we've got an endpoint. It looks healthy. So you want to port forward to Prometheus again, and we're going to take a look at the HTTP request total. Now, depending on the Prometheus scrape interval, we may just have to kill a little bit of time.
We lowered it as part of the install to 30 seconds.
Lowered it to 30. I would have lowered it before. But HTTP, there we go. Let's just graph it over. We don't even have a minute yet. How did that not work?
You need an aggregator on it as well.
Right.
So you need multiple data points for that anyway. But we're getting the metric in.
Yeah, we are. There we go. So we can see the value is 2. So we have a couple of comments. So I'll give loads a few seconds so we can maybe graph it as well. Never seen a hard-coded service IP before. Yeah, I'll blame Guy for being a bit silly with that cluster IP. I'm not sure what you were thinking there.
That's on me. I have no idea. I suspect that was me at sort of 11:30 on Monday night going, yeah, that seems like a good idea, right? Works for kind, must work everywhere.
So this raise from 2 to 3, is this sample application going to be degrading over time? Is that
this sample application is recording all requests made to it, which includes effectively health checks.
But the HTTP okay, this is request total. This is not the response time.
No.
Okay, gotcha.
No.
Okay. So yeah, that's going up to 4.
Yeah. So it's an ever incrementing counter.
Yeah, I've got it. Right. Okay, cool. I mean, it took me a minute, but I got there.
Yeah.
Okay, so now we have to install something else. Well, we can visit the app. Oh, we don't need to do that, do we?
Okay. We don't need to do that. No, it's fairly simple. Like it just shows I've served X number of requests all time.
All right. Why not then? 80. 8, 10. I'll go for a nice round 100. How about that? So now we need to install the Prometheus adapter. So is this the part that is going to allow us to use custom metrics then as part of our HPA rules?
Yeah. So if you run, so to sort of show this, you can do, you can run against the cluster, kubectl get API services. Oh, interesting. It might be API services. You might have to fully qualify it. API services.api registrations.
There we go. There was no dash.
Okay, cool. So what you can see here is all the metrics that the cluster knows about, where the service it should send it to is, whether it's available and how old it is. So you can see that we've already installed v1 beta1.metrics.kits.io being served by the metric server. Custom metrics is a different API path served by a different component. So we need to set up effectively something that is going to register itself against the API server, saying if you receive a request that matches this API path, don't try and serve it yourself. Instead, send it on to me. I will send you data back in the format you expect.
Cool. Right. Well, let's get that enabled then. Hopefully this doesn't need a PVC. Oh, yeah. Okay.
And one thing is probably worth mentioning here is, so we're using the Prometheus adapter for this example. That isn't the only option for serving up custom metrics. There's a number of other implementations. Zalando have got one called Kubernetes-based adapter, I think, which has a load of functionality. There's others that have been built by other companies and communities as well.
Cool. Is there a Google Sheets adapter?
I think the closest you're going to get is Stackdriver. And also one other thing, which I think a lot of people obviously come across this and go, oh, that's cool. There's multiple different adapters that can do different things. I could maybe get both, install multiple of them, and that way have the functionality of that one plus the Prometheus adapter plus, so I could use Datadog metrics and the Prometheus adapter. Unfortunately, at the moment, one of the limitations of these API aggregations is you can only have one thing registering itself as saying I serve these metrics. There's some discussion at the moment to build effectively a proxy that would say for this namespace, this component serves custom metrics, and this namespace, that other component. But at the moment is you've got to choose one of the solutions.
Yeah, so the problem being, if we take a look at the API services, then is that only one adapter can register as a custom metric provider. So
yes.
if you've got metrics in InfluxDB and Prometheus, you really need to pick one for these use cases.
Yeah.
All right, I'm assuming the thing you were talking about there would just be like a gateway that registers this and then proxies them onto the different handles.
Yeah. Okay. Yeah, that's currently under discussion as KEP. But
all right, and then if we hit that endpoint, we have are these all our custom metrics?
Yep, that's yeah.
So if I grab this for HTTP, oh. Nice.
And so this is where it gets interesting. So the Prometheus adapter, like Prometheus metrics are not in PromQL is not what the API server speaks. So it's sending metrics to a certain API path and expects a response back in a certain format. So Prometheus adapter is effectively sitting in the middle there, and you're configuring it as to how you want to, what metrics you want to get out of Prometheus, and how you transform them into the format that the API server expects. So you can see, one of the things you can see here is that this name pods/HTTP requests per second, that's not the name of the metric in Prometheus. We've been looking at a metric that is exposed by the app called HTTP requests total.
Yeah.
So do you want to jump to the file that we used when we installed the Prometheus adapter? So we did a bit of, as part of the command that David pasted in, we did some configuration.
This one here, there we go.
So here you can see we're doing some overriding of the default, like Prometheus endpoint it's hitting on to match up with the Prometheus chart. And then we've got these rules. So this is Prometheus adapter's configuration language. So here we're saying serve up some custom metrics rules under these queries. So in this case, we're saying any query that matches HTTP request total, which doesn't have the Kubernetes namespace blank and doesn't have the Kubernetes pod name blank. That's not so important for this sort of thing, but in case you're wanting to stop potentially exposing metrics from like PaaS containers. And then we're saying, if we come back to resources, we're saying if the name matches regex._total, perform this metrics query on the series. So do a sum rate of the series that you have found with the same label matchers. And in this case, we're doing the time window of the rate is 2 minutes. So effectively, what are the requests per second this of this metric over the last 2 minutes. Same group by, and then so all these things that are in like double angled brackets, they're effectively part of the Prometheus adapter's query language. So you can have a look at the Prometheus adapter documentation for sort of more detail on how these work, but then present that metric as this metric. You can see we've got a regex in the matches. We're then using that group that we've captured as part of the presentation of the metric. So that's how that transformation from HTTP request total to HTTP requests per second comes in.
All right, nice. So, we can actually just request that metric then, right?
Yeah.
Okay, let's see that. All right, nice.
And as back with the CPU, it uses Kubernetes internal presentation of numbers. So that's why it's had an average of 33 milli requests per second over the last 2 minutes. Rather than presenting it as like 0.0 or something, it presents it as 33 millis.
Yeah, of course. Why not?
Yes.
Okay. All right, so now we're going to use an HPA like we did with the first example to scale on our custom metric, and then you provided another deployment, I assume, that is going to generate a load to increase those number of requests per millisecond.
It's in this case it's a job, because that way we can see it scaling down again. But
all right, so we got our HPA. It looks very much like the last one. Okay, so the metrics type here has changed from resource to pods. Why would that not be custom?
So under custom metrics, there's 2 different metrics types. There's the pods, which is a metric that's exposed by every pod in the scale target, or there's objects. So that's things like ingress objects. So effectively, in that case, you're saying this is a metric that comes from a single object that maps to the pods in the scale target. But that changes basically how it does the evaluation of the maths behind the scenes.
Ah, right. Okay, I got you. So
in this case, we've got
more than one pod, so it's going to have to actually calculate that across rather than on an individual pod basis. Okay, that makes sense. I never knew that. That's really useful. Okay, so let's deploy this then. We'll just copy the paths are different. Okay. Apply case 2, and we want a sample HPA followed by load. We now have a horizontal pod autoscaler. Now we want to generate some load. Let's run get pods, see what's going on. Our load generator is spinning up. And we can monitor this. Cool. So this is going to, because you've got the -W there, is going to watch this, and what we should see is the number of replicas climb after 30 seconds, I guess, because that's the Prometheus scrape interval. Start climbing towards max pods. Yeah.
So you can see we've generated load. Suddenly the target is way above. The current utilization is way above the target, i.e., the pods on average within that deployment have each received 93.2 requests per second over the last 2 minutes instead of the target 0.5. So it's scaling up.
Yeah, and we can see that that's based on, I'm assuming, how far beyond the target we are. It's actually when, hey, we are going to need more than one of these. We're actually going to scale by 3, and then it's added on another 4. Because crap. Cool. We have a question from Sampath again. So you've asked, what is the difference between horizontal scaling and vertical scaling? I mean, we can tackle that now. We're also, I guess, we're about to show the VPA.
We've got, it depends how long we want to go. We've got external metrics as well. So in this case, we're horizontally scaling, and each new pod that we're creating here is being spun up with exactly the same resource requests and limits as the previous pods in the deployment. So nothing is modifying like how much CPU and memory each pod gets. They each get the same that we defined right at the start when we went kubectl apply deploy.yaml. With vertical pod autoscaling, instead, I mean, we'll show it in more detail later. The resources get adjusted in those pods to allow them to scale up and down to maintain utilization within each pod rather than so much across the deployment on average.
Yeah, horizontal scaling, add more instances. Vertical scaling, give the instance more power. That's the simple way. I mean, yours was much more correct, but I just thought I'd surmise it as well. Okay, so we've now hit our max. We've got our 10. HPA is working well with the custom metrics, fetching from Prometheus. Really, really cool demo. I like that. So much I'm going to delete it now. So. That was 2. All right. Yeah, that's just a fail in it. Didn't really. That's the values fail. Okay.
Yeah.
We can ignore that. All right. So we have another question. I'll come back to that in a second. Let's get any setup we need done for external metrics. So you kind of covered this when we were describing custom metrics. So we've got resource metrics, which come from the node on a cluster. We got custom metrics, which are exposed, or metrics that we can associate with Kubernetes objects. And then external metrics could be anything that we want. It could be polling how many domains end in dd146.com or whatever, right? Like it could be just that was a horrible example, but it was the first thing that came to my head. It could be any arbitrary information. We could just have it count the number of tweets on my profile in the last hour or something. Right? Yeah, that was a slightly better example. They're terrible. And to do this, what you want to do, based on what I see here, is we're going to deploy RabbitMQ and then start throwing messages at a topic and then use that as a scale factor.
Yeah.
Awesome. All right. Let's get this running then. Is RabbitMQ going to try and get persistence?
No.
We're going
I wouldn't want to say.
Ending. All right. That's a stateful set this time. Rabbit. And claim. Oh, it's got a template in it and everything. All right. Let's pull up the chart. That's annoying. Okay. The :Q exclamation mark doesn't shut down everything. Anyway, this chart was okay. So it's the Bitnami one. Oh, the Bitnami charts are a pain because I can never find the example values.
Persistence.enabled equals false, I think should do it.
All right. So. All right, upgrade, RabbitMQ, reuse values. Set, okay, so one more time, please.
Persistence.enabled equals false.
Easy. All right, okay. All right, let's give that a second. Couple more questions, comments. So Andrea says, super interesting topic. What's your take on AWS's Carpenter? Do you want to go first or second?
I will go second.
I think AWS Carpenter is firstly really good and amazing. What I find frustrating is the fact that we tried to do node autoscaling based on unschedulable pods. I think that was I mean, it's not wrong. It worked for a while, but using actual metrics and calculating your application's health and latency and understanding, or using all these other metrics to do node autoscaling, I think it's a much wiser solution. So I'm really excited to see that come out. Okay.
Yeah, I agree. I think I agree for the most part. I think like there are historical reasons why the cluster autoscaler, which is owned by Autoscaling, uses pending pods as its signal. and there are shortcomings to it, obviously. Like there's the fact that you can't really have much headroom aside from using like packing peanuts pods to like that are low priority and get chucked away when high priority pods scale. I'm really interested in like the design of it and how they're potentially aiming to basically be able to scale anything which has a scale target implementation. That sounds like it's got a lot of promise. For us at Skyscanner, like the abilities to scale on any arbitrary CloudWatch metric would be cool. I'm having some conversations with the like maintainers. They've got office hours starting from January on Tuesday evenings UK, well, European time, sort of morning Pacific time. I would encourage anyone that's interested in it to come on and have a chat.
Yeah. So, I mean, now that you've been a bit more polite, a bit more conservative in your answer, like I don't think that it was wrong, and like we should never have done that approach. I just mean that waiting until something is actually unschedulable before scaling can be optimized. Like we can try to use metrics to predict when, and we don't want a failure. It depends how quickly or how slow it is to add those new nodes to the node pool. And if that takes 5 minutes and we're waiting until something is unschedulable, you're talking potentially 10 minutes before we're in a position, and that makes me uncomfortable. So I think it's really cool, and I'm looking forward to seeing it adopted and hopefully adapted to other cloud providers too. All right, that persistence thing did not help, unfortunately. Even though the flag does seem to be correct, we still have a persistent volume claim. Although volume mode is file system. That did not work. All right, let's. Okay, I just need to try and hack at it.
Sorry about this.
Oh no, it's. I should give you a fully working cluster. Instead, I don't. I cut corners, so it was easier for me. All right. So where's this volume? In fact, what was that called before I delete it? Data. Okay. So that's not the volume we need. Volume mounts here. Yep, name data. Where's our volumes? So name data. See if we can get this working this time. Temp rabbit. I mean, that shouldn't have a permissions issue. It's going to just be that the directory didn't exist, isn't it?
I think so, yeah. So
let's just do that. And then I'll work out what node it's on, and I'll SSH in. And create the directory. Oh, no, I did not like that.
Because updates are... Okay, so is it maybe that we just tried to update something that I don't know, because Helm should have handled that, right?
Delete. Let's try one more time. And back. Now, let's just make sure this is doing what we expect. So if we did disable persistence, does it stop the PVC being created? That's probably important.
Stateful set, yeah.
Yep. That's an init container. Volumes. Okay, so yeah, it will use an empty dir, and it will not create anything. So that should be okay. Let's just assume it was some issue. there's my Wales claim. It was some issue, and we're not reusing the values this time. Did you give me a values file?
No.
So it's just all the defaults.
Yeah.
All right, let's see. And we have another comment from Justin. Nice example. Yeah, well, I mean, it it would be a nice example, wouldn't it?
Yeah.
We'll try. There we go. All right. So the Helm upgrade
Awesome.
didn't handle disabling the persistence.
Lessons learned.
Yeah, this is fun. I like it when things go wrong. Just because you kind of get to challenge some of the assumptions you made, and then I think hopefully that's useful to some people. So, we'll see.
Yeah. All
right, so we now have a RabbitMQ, and we want to deploy a publisher to this. So let me fix my PaaS. This is case 3. And we are going to upgrade our adapter with our new values file.
Yep.
Have you tested the Helm upgrade on this?
Yes, this one I did.
All right, Prometheus. Okay, so now we have to wait. Let that collect some more metrics. What we should see from our API services then is that we have something new registered for custom external metrics.
Yep.
There we go.
Yep.
Failed discovery check. I'm assuming it's just not healthy yet since the Helm upgrade.
I guess not. It's probably done the registration and then not updated itself and said I'm serving these.
Yeah, that's only 30 seconds. That's not it's not past its readiness probe yet. So let's give that at least a fighting chance. There we go. And grab for external. Much better. There we go. We now have external metrics, and what we're going to do is take a look at the value of our RabbitMQ. Yeah, not available yet. So that now might just be the 30-second delay from the Prometheus script interval.
There's also then another lag introduced because effectively the way the Prometheus adapter works is it's rather than doing ad hoc queries when you query it, it's instead doing discovery of the series against the Prometheus and telling the API server, these are the ones I know about. You can query me for these.
Right. Oh, you got a joke or something? Yeah. Okay. So let's make sure because I don't think I understood everything you said there. Okay, so we upgraded the Prometheus adapter. Let's take a look at the values file we've modified there then. Let's see what's changed. So still the Prometheus thing. Okay, we've added our extra. Yeah, that's the old one, right?
Yeah,
okay.
Yeah, that's exactly the same as the old one.
Okay, and so we've added this new external section, which has got a new series. For hand. Okay, so this is just fetching queue length, size, and messages.
Yeah.
We're saying this applies to. I don't want to guess. Why don't you walk through this?
So one of the things that I mentioned before is that the Kubernetes API server is making these requests. Sorry, the HPA originally is making these requests through the API and then they're getting proxied. They're made in a really specific pattern. So if you jump back to the query that wasn't working against the kubectl get raw, you can see, we'll figure out why that's not working. You can see that it's making this call to external.metrics.his file, then an API version. That's fine. And then namespaces, then a namespace name, and then the metric. So if we then jump back to the written up config, what we're saying here is that this series actually has a label called Kubernetes namespace. So if you scroll a bit further right, so we've got a label on this metric called Kubernetes namespace, and what we need to do is map that into make sure that metric is served up under the path that Kubernetes is querying it on. So in this case, we're saying use the value of the label Kubernetes namespace, and actually that becomes the resource namespace label when the HPA is querying for it. You can. There's also, if it was a pod specific metric, you might also need to, or you might want to basically use the value of a different label as the pod metric. So when we were doing the custom metrics example, you can actually query for a specific pod's use of value for a metric. So you can basically map that label value into, say, this is the pod name, even if it's some weird label because of the way you're exposing it somehow.
Cool. Okay. So we probably want to work out this.
Yep. First things first, let's see if the metric is getting into Prometheus.
I thought the same. Great minds. Oh, yours is great. Mine's is all right.
I wouldn't say that. I'm just, yeah, we were port forward into the service before.
And it's still here, so let's refresh. And what we want to see is, do we have, oh, we do not.
Nope. So let's jump to the status targets on the Prometheus.
Okay. So
does it even know about the targets? So if you search for a rabbit.
It is deadline exceeded. All right, let's try that then. So let's get pods, port forward, rabbit. What port was that on? 9419. Okay. No.
No, doesn't look healthy. Okay.
Oh, well, yeah, that's just actually, oh, it does say running, right? Yeah. Okay, let's take a look at, is that port number correct? 1439? Oh, wait, something, this is an error message. Readiness probe.
Unable to perform. Ooh. Might this be? How good is the headless service support in?
Yeah, it should work.
Yeah.
Let's check. We've got endpoints. Yeah, that looks okay.
Yeah.
Okay, let's describe pods. We'll try a couple of things. We can always jump onto the VPA and come back down. So what is this actually telling us? So it's trying to speak to, okay, so actually the service name is supposed to be RabbitMQ headless. So that looks good. Okay.
Yeah.
It's got endpoints. I mean, both those services actually look headless, but okay. See, Node Rabbit not running at all.
No, that's a suggestion to start the node.
I mean, the way that we fix everything is to delete the pod, right?
Have we had a look at the full logs, or are those?
Oh,
logs?
we don't even look at the logs now.
No.
Looks good.
Yeah.
Is those events old? Where's the probes?
Did we make the mistake of trying to upgrade rather than reinstalling from scratch? Again?
No, it's ready. Okay, those events are old. I think it is healthy now.
And yet,
I don't know. Take a look at this. What do we got? Where's the ports? All right. 9419 is the metrics. Okay. Let's port forward. 9419. I'm not making a mistake there. Like that's right, isn't it?
Yeah.
9419.
Yeah.
9419. Metrics. I'm going to delete the pod, and then we'll see if those events disappear, and then we'll do the VPA, and then depending on how we're looking for time, we may look back. So
yeah.
And I'm sure if you want to try this in your own time, it works in kind, and potentially something to do with the changes we're making live. So we'll see.
I mean, it wouldn't have been a live demo without something failing properly hard.
Maybe better now. Let's try that again. Empty response is probably better.
Yeah.
Or not. No, it's not healthy yet. Bugs starting. Okay. Last chance, Rabbit. Come on. You couldn't have used Nats, no.
I thought Rabbit was the easy choice.
I've never really had much problems with Rabbit in the past, to be fair. So let's go on to the VPA. We'll come back to Rabbit.
Okay. Yeah.
All right. Okay. So let's see what we got over here then. Good comment there from Justin. Because we have disabled persistent storage, it may struggle to initialize the second time. I mean, it should start from fresh, I hope. But we'll definitely try that. I might do a Helm uninstall and reinstall when we come back. In fact, I'll just check one. Should we delete it and then come back to it? Or will I leave it?
Let's delete it and come back to it.
All right. Fun. All right. So persistence disabled. Let's just leave that while we do the VPA. Okay.
Yeah.
So vertical pod autoscaling, as we just said to people, horizontal means add more of the thing. The vertical pod autoscaling just means tweak those resource limits that we have on our objects.
Yeah.
We're using Cowboy Sys. What's Cowboy Sys up?
It is. I can't remember who they're tied to. It's a set of quite useful charts. You can have a look at them on Artifact Hub. So there is some security scanning, etc.
All right. So we add that. We're going to deploy stress deploy from example 4. Stress deploy. And
we'll probably need to up the memory again because this is a familiar one.
All right. Okay. Oh, it's okay. Oh no, that's the autoscaler. I love that everything is just going to this default namespace. Yeah, omcal. Okay. So let's VPA. Okay. All right. So what was it we said we needed here? It was.
I think it was like 270 gigs in that. It's 270 megs, sorry, in that one.
It was 1 gig down here, wasn't it?
Yeah, 1 gig or so.
Okay, let's reapply or deploy. Any labels on these just to make filtering that a bit easier?
There's an app one.
Yeah. Pods. Okay.
I may have increased the memory scaling on that one from the previous example.
Let's go with. Okay, it's happy.
Okay, cool.
And
just check the CPU one as well.
Okay, so let's bump that up. In fact, that'll probably just be the CPU here, won't it? We did bump that up in the last one too. So I don't want to break your actual scaling of that. So
Yeah.
we can tweak as we need.
Yeah.
And that's now healthy. Oh, it was healthy.
Mm-hmm.
Got ommed. I don't know why I'm being so specific with those numbers, but creating, running, all killed.
Looks better. Okay, cool.
So if we do this, let's actually see. Let's try and get those limits down to close, so the VPA can actually do stuff. I guess, right?
Yeah, that would be better.
So our CPU. Why was that being killed? It's using 3 meg.
I think that might have just been like grabbing it before the pod, like once the pod had started up, but not actually started going, I'm here to stress your stuff.
Right, of course. I keep forgetting about that delay. Right, so we need 1100 meg on memory and 80 on the CPU. So let's do that first. So we'll say request 80 memory. 1100. So we know that's the baseline. So the requests will be our baseline.
Yeah.
And then we're going to set some limits. So we'll say 100 and 1200 because we're being really stingy. So we're not really giving it much wiggle room there.
Yeah.
Now let's see if our CPU one. Yeah, there we go. Okay, so we want 800 millicores and 30 meg. So 800. That's sneaking in then. That's actually being throttled right now.
Yeah.
I cannot remember basic numbers. Right, okay. And we'll say, yeah, you can stretch to 1,000, and we're only going to give you 42 here. So that's it. Pretty finely tuned, I guess.
Yeah, pretty finely tuned, like bumping up against its limits.
If we grip on stress, I should just return those two. There we go. Okay. Oh no. They're both being killed.
I think it might be one of those ones where they're actually like bumping up and down with the memory, and depending on when you get it, it's potentially a useful a metric or not.
Oh, all right. I guess we can tweak the VPA anyway, so.
Yeah.
150 should cover everything, and let's just say we know it didn't really go much bigger than that, so.
Yeah.
Okay. Oh, that's the old one. Okay.
Yeah.
Running and running. Do not touch anything. Nope, memory dead.
No.
Let's just start speaking in numbers at likes. Okay. Oh, I've got the W. I was wondering why that wasn't actually doing the watch, and it's because of the. Right. Okay. Running. No kills.
The CPU stress one that's running is the older one, though.
Oh, so it is. All right, let's bump up the CPU one. So I guess it's just eating a bit more memory than I thought. I'm so confident I'm not going to have to tweak that again. I'm just going to go to the next step.
Okay.
So let's take a look at our VPA. Okay. VPA. All right, you want to run us through this?
So yeah, this is so you can see this is like under an API version autoscaling.case.io kind vertical pod autoscaler. So this is a custom resource definition. Some people may be familiar with them, some may not. But this basically is an extension of the base Kubernetes APIs with a new custom resource, and this is effectively declaring an instance. So that means you can then interact with it using kubectl. And this custom resource, these custom resources, sorry, are picked up by the vertical pod autoscaler and used to inform it about what behavior we want. And it also writes back status to these custom resources so that we can basically have a look at what it's saying about what behavior it intends to undertake. So in this case, we give it some metadata, a name, usual thing, we expect that. And then as with the HKs before, we're giving it a spec, so a target ref. In this case, we're pointing it at the CPU stress app. And then this is where the magic of the VPA comes in. We're giving it a resource policy. So we're going to need to tweak this because we've had to throw up the resources.
So that was going to be my first question. It's like right now we have both of these running, but we bumped them a little bit higher than we wanted.
Yeah.
Could we? I don't know how the VPA works specifically. If we just put this back down so that they're both killing and apply the VPA, will it fix it?
It can potentially run into issues. So the problem is it's pulling its data from the metrics API. So if these things are repeatedly killing, and therefore the metrics API is giving a misleading idea of how much resources these pods are using, it might not be able to do the maths it needs to do to figure out, oh wait, that needs more CPU or memory.
Okay, so this CPU thing on the stress program, does that mean consume 4 CPUs?
It means run it on 4 threads.
Right, okay. So if we've got this at 1500 and 500 and we go to our VPA, does that mean that we want this minimum? I mean, the minimum probably has to match, right?
Yeah, in this case.
So 500 M and 1500 MI. And then we can say down here, you can have 4 whole cores and 3 GI.
Yeah.
And that should work for the memory and the CPU. Although we're only targeting the CPU one for this.
In this case, we're only targeting the CPU.
Got it. Okay.
And you can also basically tell it actually only monitor and modify. So, for instance, if you're running a Java app where it may be always appearing like it's using all of the heap, therefore the memory utilization to Kubernetes always looks really high, you may only want the VPA to monitor the CPU and never to modify the memory.
Okay, cool. So I just apply that. Is it going to do anything?
So if you apply that, and then we can have a look at the logs of the vertical pod one of the vertical pod autoscalers components.
Describe. So there's no events. That means it's not doing anything yet, right?
Not yet.
And that's because, again, we've got to wait for Prometheus and all those metrics to do something.
Actually, no, sorry, I tell a lie. It is already picked up. So if you jump back, so you can see that it's got these conditions, status conditions. So status is true, and it's provided a recommendation. And you can see below that the recommendation.
Okay, so we have, what's the lower bound here in this context?
So the lower bound is I'm trying to remember exactly the maths. The lower bound is how much.
Is it this?
No, it's how much it's used. I can't remember exactly.
All right. So what does this recommendation suggesting right now? Because I'm not sure I understand. Is it telling it to increase it? Is it telling it?
So if you scroll up a bit, again, so there's basically there's the update policy, update mode. So VPA has a number of modes it can operate in. So there's auto, recreate. Currently, those two are the same, which basically says when you do this, recreate the pod to change the change the resource stuff. So basically, it says if you think that we need to change the resource requests on this, delete it, like remove an existing pod to trigger recreation of the pod with the new recommendations. There's initial, which basically says, like, if a pod has been assigned resources, never delete it to force recreation of it and give it new resources. The reason auto and recreate are different is because auto in the future will hopefully be able to do in-place updates of the resources on pods, and therefore be the recommended way because it's the least disruptive. And then there's also off, which basically allows you to, if you're unsure about the VPA and how it might affect your workloads, you can basically install the VPA, say, watch these workloads and like record your recommendations, but don't actually do anything about them.
All right.
So that's what the recommender is doing. There's then other components in it. So there's the updater. So check that then takes the recommendations produced by the recommender, checks whether the managed pods being monitored by that VPA CRD have the correct resources set, and if not, it kills them so that they can be recreated by their controllers. So the VPA doesn't actually operate on, it doesn't change anything in the deployment that it's monitoring in this space. It instead has the third and final component, an admission plugin, actually make changes to the pods when they're created. So effectively, the API server, the deployment in this case goes, if a pod's been deleted by the VPA, goes, oh, that's been deleted, I need to create a new pod to match my desired count, create a new pod, and that the API server passes it through the admission plugin, which takes the recommendation, pulls that in, sets the resources.
Ah, okay. All right. So this, so you're suggesting we can take a look at the logs from the recommender?
Yeah.
Home event will be discarded because it's too old. All right. Yeah, I think that's unrelated, isn't it? I think that's what we were tweaking with the thing. Then we did a describe, which we just did. So now we can scale this up. Sure what I'm looking for here.
So if you now have a look at if you describe the pods that match the label selector, describe pods -L app equals CPU stress app.
Yep. It bumps our limit up.
Yeah.
Oh yeah, because our limit was 1,500, and it's now decided you probably want this at 1,700. Okay. Phew. All right, that's the end of the VPA one. Nice. Okay. Yeah. Moment of truth. There's Rabbit.
It's running. I still had one restart.
Let's see. Oh, I think I'm getting metrics.
No, doesn't look too happy.
Port forward, service, Prometheus. Right. And if it works, no. Okay, we don't have. Oh well, never mind. Not a big deal.
Yeah.
Cool. Awesome. Let me pop that off. So if anyone has any questions, we're going to finish up in just a few moments. You can get them in now, and we'll do our best to tackle them. I think, thank you, Guy, for putting all that together, and just giving us that kind of running commentary as well, and explaining all those concepts and the vocabulary. I think using the HPA and the VPA is really important when adopting Kubernetes, and it's just nice to have an example like this where we can sit and go through it from start to finish and really break down and understand what's actually happening within the cluster. Your description of the resource metrics, the custom metrics, and the external metrics was all fantastic. That's something that I've had a little bit of confusion about in the past, so it was good to kind of have that explained to me in really nice detail. Why don't we just wait for one more minute? Like, tell us a little bit about SIG autoscaling. How long have you been the chair? What does that mean? And can people get involved?
Yeah, definitely. We're definitely always looking for more people to get involved. If people have like use cases that aren't currently covered by the components we take care of, so SIG Autoscaling currently has ownership of the cluster autoscaler, the HPA code within core Kubernetes, vertical pod autoscaler, and something called the pod nanny / add-on resizer, which is a really sort of simple / dumb VPA basically. So it basically just scales it up and down in proportion, vertically in proportion to the size of the cluster or something similar. There's some plans for us in terms of like what our near timeline looks like. We want to, so you saw a lot of those APIs we were using were V2 beta 2. Autoscaling V2 beta 2 API has been around in beta for quite a long time. We want to look at promoting that to GA. There's some bits of functionality that are still in alpha that we want to try and get into beta and GA to basically enable people using managed services, a lot of which decide to restrict people to beta and above feature flags. We want to try and get those promoted so that people can make use of them wherever they're running. And yeah, we've had a lot of functionality and new bits of functionality pushed through by users saying we want this. I've not included it in the demos yet, but there's some really cool functionality called scale policies, where basically you can get really granular with how you want a service or a deployment to scale up and scale down. So you can say, at most, I want like to scale down at 10% of the pods in this deployment, or 8 pods at a time, whichever is the highest or the lowest. So there's a lot of granularity you can get in that, and that users have implemented. So yeah, I've been co-chair of the SIG since earlier this year, April time maybe. Time has lost all meaning, like it has for everyone. And yeah, I've tried to sort of bring a more end user focused sort of view of things, because a lot of the people with heavy involvement and maintainers of the code are very much like Google, so like they're providers and they get feedback from like users of GCE and GKE, sorry, but like I've tried to sort of bring a more like I'm dealing with clusters in Skyscanner day to day, so yeah.
All right,
but
thank you.
We have office hours every Monday at 4 p.m. Central European time. Come along if you have any ideas, things you want to discuss.
All right, thank you very much. We got a comment / question. I'm not sure. So firstly, Justin says custom metrics is my favorite. Yeah, I can definitely understand why custom metrics, the very powerful demo that we had there. And then idea, cron-based horizontal pod autoscaler, changing the scale policy on a cron interval. Yeah, I think there may be a use case for that. I mean, I can think if you're an e-commerce or you're a news outlet, you might want to scale set differently between office hours, between 9 to 5, or maybe you want to lower your scaling policies in the evening or during the night. Yeah, definitely. Cool idea. All right. I know you've got another call to get to, and we've been over time. So thank you for sticking with me and sharing your knowledge with us. It was really, really good. And other people can check out that repository, have a play, and enjoy.
Yeah, let me know what is lacking. Obviously, I need to go back and revisit the limits for those stress deploys and figure out why Rabbit doesn't work on Equinix. But
well, if you would like a bare metal cluster to play with, I will make one all for you. Not a problem. All right, you have a great day, Guy. Thanks again for joining and sharing your knowledge, and I'll speak to you again soon. Bye-bye.
Thanks. Bye.